Hi, this is part 2 of the NuTone NM100 Master Station repair video. And if you haven't watched part 1, you probably should, because that'll take you up to the point that we're at today. When we last saw our NM100, I had gone through the process of doing what I call Intercom Triage, which was simply swapping in and out the original boards for the NM100 that was dead with replacement boards that I have to figure out which board was most likely causing the situation where it was dead. Through a process of elimination, we determined at the end of the video that the problem was with the original microcontroller board that was in the NM100, and we knew that because I installed a replacement microcontroller board that belongs to the shop, and when we did that, the set came back on, and although we didn't test it thoroughly, for all intents and purposes, at that point it looked like it probably was working correctly. So we knew it was a problem with the original microcontroller board. My next step, where I left off in the end of the last video, was to work on the original microcontroller board and see if we could figure out what was wrong with it and see if we could fix it. Between the time I shot the last part of the last video and the first part of this video now, I spent a lot of time working through the microcontroller board that was dead. And I went through very carefully, and I measured and I tested and I worked on it out of circuit or disconnected from the rest of the boards just as a board itself, looking for something that was obviously wrong. And then I cobbled the set back together again and worked on it when it was live. And one of the fundamental steps you do in troubleshooting any board, especially a board that you're not really that familiar with yet and you haven't worked on very many of, is you measure voltages. You're looking for places on the board where the voltages are right and places where the voltages are wrong. And what I found on the microcontroller board was it seemed as if a lot of the board was fine. However, the voltage to power the microcontroller, which is down here, they were all out of spec and off. Now, the schematics that I have, there are no voltage charts. So some of it you can reason out, and some of it you have to make general assumptions about based on what the parts are and the type of circuit that it is. And you know sort of within a ballpark's range of where the voltages should be, and the voltages to the microcontroller seemed way off to me. So then you backtrack through the circuits looking for something that would cause that, and I probably went through the board at least 3 times in great detail looking for a problem and really couldn't find a fault that would cause that. I actually went to the point where some chips were removed and individual components were removed and tested out of circuit, because that's more certain sometimes than testing them in circuit. And for the most part, I couldn't find anything that was the root cause of the lack of proper voltage to the microcontroller. At that point, it seemed to me that the only logical thing that was left that could be causing the problem was a problem with the microcontroller itself. So I decided to take a more bold approach, because you know what they say, fortune favors the foolish. And I went ahead and I removed the microcontroller from the circuit board, the one I suspected was damaged or faulty. And then I also removed the microcontroller from my substitute replacement board that we know worked, because we saw it work at the end of the last video, and I installed it on the original board. Now, that was a somewhat of a bold thing to do, because if there was a problem on the board in general that caused the microcontroller to become damaged, installing a new microcontroller on the board that you know is good and is working is a risky thing to do, because if you haven't found the other fault, you could simply kill the replacement microcontroller, and then what do I have? Then I have 2 dead boards, and that would be bad. But that was the only way I could see to reasonably go through it and prove out what I thought, which was we had a bad microcontroller. Replacing the microcontroller itself is a moderately difficult, it's not a hugely difficult thing to do, but it's moderately difficult, because what you have to sort of understand here is, and it's a little hard to get perspective, is that this IC, this chip, it measures about 3/4 of an inch square, and there are 100 pins around the perimeter of the chip. So there's 25 pins on each side. So the pitch or the spacing on the pins is very, very small, and you have to do it very carefully. Of course, this is why we have a microscope and we have ultra small soldering tools, because while you can, when you remove the chip, you use the hot air station and flux to melt the solder and remove the chip. And you can, if you're really talented and very practiced, you can reinstall the chip in that method also, but we haven't done that many of these yet, and I wanted to be certain to get it on there properly because the spacing on the leads is so incredibly close together. You don't want to bridge any of them with solder. The way I like to do this is you put it in place, you get the pads all ready and they're all clean and it's ready to go. You place it on the board where it belongs, and you individually you tack down one lead on one corner and then another lead on the opposing corner, making sure that all of the little legs are sitting in the center of their pads as much as humanly possible. And I'm sorry I can't zoom in on this more than I have right now. I have to get a different lens to do that, or I'm going to get a microscope camera pretty soon. And then you go through one by one with the ultra small soldering iron, and you actually tack down and solder each individual leg. So it's a fair amount to do. In the end, once it was done, and I was certain after inspecting it at least 2 times to make sure we didn't have any solder bridges, I went ahead and installed the board back in our mock-up with the original main audio board and the power supply, and lo and behold, it worked. So that proved to me that, and the voltages on the board all of a sudden sprang back to where they're supposed to be, and that proved to me that I was on the right track, that the original microcontroller was indeed bad. You might think, well, yay, that you figured it out. Well, it's yay, yeah, I figured it out, but also it's not a really good situation, because while I can order a microcontroller from our component supplier and I can obviously mount it onto the board, it's not going to do me any good, because when you buy a replacement microcontroller, it's blank inside. There's no program, there's no firmware, there's no information. There isn't anything that makes it work to make the NM100 be a NuTone intercom system. The programming of the microcontroller was originally done when these boards were manufactured at the assembly house, and either it would be that the microcontroller would be programmed and then installed on the board during manufacturing, or more likely it was installed on the board and then it was programmed once it was on the board by a programming jig that the assembly house had. Now on this particular board, there is a spot up here where a header could be installed, and if you have the right header and the connections and you have the right terminal program, you can actually connect to the board with a computer. However, without having the program to program the blank microcontroller with, it doesn't do you any good. So we can get the part, we can install the part, but we can't, and we have a way to program the part, but we don't have a program. NuTone has the program. Now, whether they actually have a program somewhere or it was at the assembly house, and a lot of this gets lost through time, or simply that they're not willing, no one's willing to share the program. They don't want you to reprogram chips and do those kind of things because it's part of their intellectual property, and we don't want anybody bootlegging NuTone intercoms or anything like that. So a dead microcontroller on an NM100, it's the same problem as a dead microcontroller on an IM3303 or a 4406. There is no real solution other than having a replacement board. Got far enough along to prove that the microcontroller was the problem, and I had what seemed to be a fully functional set. At that point, it was time to do more elaborate testing to make sure that everything actually was working. And the easiest way to do that was to reassemble the set back into the faceplate, because it's just easier than having boards flopping around and all that kind of stuff. So I reassembled the entire set and went through a complete operational checkout on it. And at that point, everything seemed to work correctly. The radio played, the tuners worked, the memory presets worked, the intercom worked correctly. Everything about it seemed to be right. And then it was time to plug a chime module into it. And when I plugged the chime module into it, unfortunately, we had a surprise. While the chime module does ring, and it rings through the system at a much lower volume than it really should. And it's not the chime module because I tried several different ones. I tried the one the customer sent, and I also tried a couple that I have. And I know the ones I have are good, and they're all the same. So it's a problem with the intercom, not with the chime module. So based on the schematics and what I know about troubleshooting inputs for chime modules, I was fairly certain that the problem would be on the main board. So this is what we call, this is the main audio board. And troubleshooting chime module problems on real NuTone intercoms is not really all that challenging at that point. We see a lot of 3303s and 4406s with lack of chime input or low level chime input and those kind of things, and those circuits are fairly well understood and they're fairly straightforward to work on. And it's not really all that challenging. You know, it's like a 10 or 15 minute thing to do in addition to all the other work you're doing on a set. On the NM series and the DMC series, it's a little bit different. And what I discovered in looking over the schematics and figuring out what approach I was going to take to try to find the source of that particular problem, I discovered something really interesting. So this board, this is the board that came out of the customer's NM100, and this is another NM100 board. And they are very different. The customer's board is a revision D board, and this one is a revision C board. And these two boards are actually very, very different. Differences in these boards are fairly major, and they have to do primarily with this section here and this section down here. And if I sort of hold them up here, you might be able to see they are very different. So let's look at the early board first, because this is the board that more closely matches the schematics that I have. Now, the schematics that I have are earlier than when this board was manufactured, and I'm sure there were a certain amount of revisions and modifications made to it over time, so you expect some changes, but minor changes, you can work through those and reason your way through them and all that kind of stuff, and that's pretty much what you're able to do with a board like this. The early C revision board, this area right here, this chip right here, it's an LC75372E, and it's a Sanyo chip, and it's an electronic volume control for car stereos. And yes, a lot of components used in intercom systems are similar to components used in car audio. This pretty much does what you would expect a chip like this to do. It gives you volume control, balance, fader, bass, treble, loudness, input switching, all of those kind of things that a chip like this would normally do, whether it's in a car or in an intercom. And this is not a mysterious chip. This is actually a fairly easy chip to understand, and it's not an expensive chip, and it's something that's been around for a really long time. When we move to the revision D board, we find something very different. Here on our revision D board, you can see this area of the board would be the same area as the earlier board, but we see entirely different layout. And what we have here is this chip. This is a chip made by a company called Princeton Technology, which I think is a Chinese company, and it's a part number PT2313E, and it's also a stereo audio processor chip for car audio, and it does all of the same things that the Sanyo chip does for the most part. However, we've got something very different right next to it. Right here, we have this little chip, and this is a microchip PIC16 8-bit microcontroller. So what's a microcontroller doing here? Because there's been no microcontrollers on any of these other main audio boards up until this version, and the schematics that I have, they don't show anything like this at all. So this is a mystery at this point. And the problem with something like a microcontroller, when you throw it onto a board like this, is what is it doing? So this is a mystery. Now, I'm not saying that any of this change has to do with the problem with the low volume on the chime module. However, this is a drastic update or a drastic change to a board that they've been making for nearly 10 years. And without any kind of documentation as to what this little microcontroller here is doing, it's going to be really tough. What all this means is the set's not done yet. I'm still working on it, and there will be a part 3 because I have some large blocks of time set aside to work on this, to try to work through this board. And what that really means is, let's move this one out of the way. What that really means is it's sort of like reverse engineering the board. Since none of this is on the drawings that I have, I now have to sit down and go through it circuit by circuit, trace by trace, lead by lead, and try to draw out where everything goes and then try to reason out why they put it there and what it's doing. Now, it could very well be that the low chime volume problem has something to do with this part of the board over here, and it has nothing to do with this at all. And so it's going to take a lot of time and effort and thinking to try to figure out what the problem is and what all of this is about. And having the microcontroller on this board, it brings up the same problem and situation that we have with the main microcontroller board, which is if this microcontroller develops a problem, it's not a repairable part. And since it's not a replaceable part, and since we can't replace it, then sets that have a problem with that mean that the only way to repair it is by replacing the entire board. Now we're talking about if you had a set with 2 bad microcontrollers, you're talking about replacing 2/3 of the boards in one intercom. And now we're starting to rapidly approach the territory of it's not economically feasible to repair it any longer. So this is not a good situation. This is the end of part 2. Part 3 will be, I don't know, when I get it figured out, I hope. If we can get it figured out. This is not going to be easy. That's where we are right now with our NM100 master station repair. I hope you found this interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube because that always helps. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. Wish me luck. See you on the next video.